All right, we're on to L2-02, where we're going to continue working in sketch mode. But this time we're going to work on sketching a slot and also working with the spline tool. This is something that I haven't used a whole lot of, but it's super powerful. And that allows you to make complex curves in a pretty easy way. So for example, if you wanted to make like a vase, like a 3D printed vase, or even model a vase that you were going to go then make by hand, this would be one way to get the nice, the curves that you want in a much easier way than, say, using a bunch of line segments or arcs or whatnot. So Spline is a really nice tool. It's just something I haven't used a whole lot of. So this will be good practice. We're going to use the same sketch as the last time, or sorry, the same file, not the same sketch as last time, called sketch practice. You can see this sketch is still visible on the XZ plane. We're going to go ahead and hide that simply to make our life easier, and create a new sketch. And this time they've asked us to use the, I believe, the YZ plane. So changing it up a little bit. YZ. All right. All right, we're going to do click create spline fit point spline. In the canvas area, place the first point in the upper left quadrant, the second point above the above the origin, and the third point in the upper right quadrant. All right, easy enough. Create spline fit point spline. And when they say above the origin, again, the origin is this little target looking thing. They just want it directly above. We've got the blue dotted line, meaning that it's snapped to the vertical above the origin, and then into our right quadrant. Cool. Click the green check mark to end the spline. Okay, cool. So there it is. Real quick, for those of you that don't know what a quadrant is, we have the negative side of, I believe this is the X, the negative side of the Y, the positive side of the Y, positive side of the X. So there's it creates 4 spaces, and we call those quadrants. All right. Click Create Spline, Control Point Spline. Repeat the same process used in step 5 to draw a new spline below the origin, below the original spline. Okay, control point. We'll do the same thing. It doesn't say anything about with respect to the origin, so we're just going to do that. Okay. On the first spline you drew, each point has green handles. These handles can be manipulated to influence the spline's curvature. The handle's angle influences the direction of the curvature, and the handle's length influences the weight of tangency. So let's see what the heck that even means. So this defines the angle of the spline, while this defines the curvature, or the magnitude. Okay, so you can draw the green line in or out. You can also change its angle, and you can see how it affects the spline as well. You can see now how, like, making a complex curve for like a vase, if this were vertical, if you will, and this was the wall of the vase, that's kind of what I was talking about earlier. Similarly, I believe we have, well, we only have the green line in one spot. I thought we'd have another couple. If your spline was longer with more points, which is possible, you may have more than one green line available to manipulate the spline. In the sketch palette control panel, activate the curvature comb option. Okay. Additional graphics are added to the spline to help you visualize the spline's curvature. Continue to manipulate the spline's handles to influence the geometry. The middle control point can be deleted by selecting it and pressing delete. All right, so let's see, backwards here. Sketch palette control panel. sketch palette. Hey, where are we? Okay, let's see. Click on that. All right, there it is. So here's the control panel here. You have to actually click on the spline in order to pull up the splines control panel, and I'm going to click curvature comb. All right, and there we are. I was looking for this other magnitude line, and I, for whatever reason, couldn't see it earlier, but it is in fact there. So you can change the magnitude and the direction, also using that, and see how it affects your curve. For the second spline you drew, drag the control point between the two dashed lines and notice how the spline's curvature reacts. This one makes a little bit more sense to me intuitively. The control point spline, but I guess it's whatever gets you the geometry that you want. So there it is. If I drag it this way or this way, the arch kind of follows. That's a little more intuitive, I think. Okay. A center point can be added to the spline by selecting the spline, right-clicking it, and then choosing the Insert Spline Control Point option from the pop-up menu. All right. Insert Spline Control Point. So I right-clicked. Ooh. I'm going to click on it. I have to do that. Again, I just clicked on this. I right-clicked, and Insert Spline Control Point is on the is one of the options. And we'll see kind of what that means for us. So one thing that might be kind of a fun challenge in this lesson is try to create the same curve or a similar curve using the two different methods. So if I want to make kind of an S shape, okay, like that, and try and mimic it up here, I'm not promising anything right now because this is new to me. I also don't like this comb here. I don't know. The curved comb freaks me out. So, all right, so we know on the, let's work on the left side first. So we know that we start angled down on the left side. Let's get our points in the right spot too. So the center point kind of runs there. This guy sits up. This guy sits down. And I don't really like this. Okay, okay, we're getting close. So, all right, I could fiddle with this more, but you can see that the shapes are generally the same. You're starting on the left side with it sweeping down. Okay, it comes up. It's like a sine wave. Comes up with a maximum here, dips back down through the center point. You have a local minimum, and then it shoots up on the right side. So that might be kind of a nice challenge for you to try between the two different types of splines. Again, I like this one more. I think it's a little more intuitive, but either work. The newly added control points can be adjusted to influence the spline's geometry. Okay, we've finished exploring this at this point. Click the Finish Sketch button to end the sketch. Okay, cool. In the browser, click the eyeball next to the sketch, the second sketch, and hide it. All right, and create a sketch choosing the front face or the XY plane. All right, they're having us use all the planes this time. So we've done pretty much all the planes except for XY, which for us is the bottom. All right, click Create Slot, Center Point Slot. Slot, center point slot. Okay, and again, if we look here at slot, there is 5 different ways to create them. All are going to have their own specific ways of defining the slot and steps in which you do that. And so I'm guessing they're going to describe to us here how to use this specific one. Place the slot's first point at the sketch origin and place the second point roughly 5 inches to the right. All right. Okay, I'm just going to put in 5. Okay. So what we've just defined is the length, or rather half the length of the slot, with those first 2 points, and the third point is going to define the diameter of the slot. And what do they want the diameter be? Says just click a third point arbitrarily. So there we are. I'm going to minimize our sketch palette. All right, click create slot, center point arc slot. Choose one of the endpoints of the original slot as the new slot center point. Move the cursor to the right and click a second time to determine the slot's radius. Then click a third time to determine the new slot's endpoint. All right. Oh, not circle. I think it said center point arc slot. Is that right? Is that what they wanted us to do? Center point arc slot. Right. Okay. Choose one of the endpoints of the original slot as the new slot's center point. Well, that's a little bit vague, but I believe they mean this as the center point. So that when we click this, yeah, it'll define the slot just like that. So that wasn't that was kind of poorly written in that the end point of this slot, even though the end of the slot itself is right here, this is the end point that they were referring to. So I clicked above the end point to define the radius so that it would follow the arc here of the first slot. And then I just followed it around as far as I wanted to. Now, if we wanted to have these lie on the same line, one thing we could do constraints wise is, let's see. So one thing we could do is, and this isn't the most straightforward thing possibly, but it's what's coming to mind now, so that these 2 points lie on the same line and this slot is kind of exactly, say, a quarter of a circle. And we haven't done this yet, so this will be good. Create a line that starts at the origin, okay, and just runs horizontally out some arbitrary distance. And escape. Okay, what we're going to do is we're going to highlight that line and go to our sketch palette. And under line type, we're going to hit construction. And a construction line is a different type of line in that once you finish the sketch, it can't be used to define anything in an extrusion. So it's kind of like an invisible line to the part itself, but it allows you to constrain and dimension off of something in a sketch, which is pretty handy. It allows you to construct your sketch without interfering with later extrusions. So we've created this flat horizontal line that we can now create a coincident constraint between this and this. And we'll do the same. We can even do the same here. Click OK. My computer's a little bit laggy. All right, we're going to click here, sketch palette. Coincident, this and this. Great. So now we've created a slot here that runs exactly a quarter of the circumference of this radius right here. We could go ahead and define that radius if we wanted to. I know I'm getting away from the tutorial, but it's exactly 2.5. There you go. So now you know the radius at which this slot path is. Okay. That was a complete tangent. Click Create Slot, Center to Center Slot. The first click indicates one of the slot's endpoints, and the second click indicates the other endpoint. So before, the first click indicated the center point, and the second click indicated an endpoint. So you're going to effectively mirror the slot on the other side. This is defining the overall length. It's just a slight nuance, a slight difference. And the third click in both instances defines its width and therefore the diameter of the arcs on either end. Slot, and they said center to center. So I don't know, we'll do that just wherever we want. And let's put it at 10 inches like they had it. And I don't know what they had on the width. Let's just say 1.5. Simple enough. So if we were to come in and dimension this, we would know that it's 10 because that's what we input as the end-to-end length. All right, we're done. That's it on slots and splines. Splines come in super handy when you want complex curves with I would say one, I mean even one, but certainly two or more nodes at which curves occur, like compounding curves occur. Slots are obviously really nice. I mean, you could go in and make a slot just like this simply with lines and circles. And using some of these modify tools like trim, which I think we'll get into later. So you could make this without using the slot tool. The slot tool is just a lot more effective and a lot faster at doing it. So something worth utilizing. Cool. Done with this one.